Okay, good morning, everyone. Thank you for joining us for the November installment of our monthly webinar series. My name is Brian Murphy. I'm a marketing specialist here at DISYS. I'm pleased to welcome Amer Abbas, DISYS's Vice President of Global Services. Amer is going to be covering an array of topics encompassing cloud enablement. If you have any questions, please type them into the chat box, and I'll go ahead and address them at the end with Amer. Amer, you want to go ahead and take it away?
Thank you, Brian. Good afternoon, everybody. My name is Amer Abbas. I am the Vice President for Global Services at DISYS. Thank you very much for attending our discussion on rapid application enablement in the cloud. This presentation is actually broken into two components. First, we'll talk a little bit about sort of what's happening in the marketplace from a cloud perspective. A lot of buzzwords, a fair amount of marketing hype around it. So we wanted to get a little bit deeper into really what is cloud, what does technology underlying cloud look like, why is it sort of different from any of the existing infrastructure technologies, and then in the second half of the presentation, get a little bit deeper into how do you get applications onto the cloud, how do you manage them, and then talk a little bit about some of the work that we've done within that specific area. As Brian mentioned, we welcome all questions. You can type them into the question box, and then we'll address them as we go along in this presentation as well. The other item that I'd like to point out is that this presentation will be made available to everybody this afternoon after we're done with the presentation. So let me actually get started. There are a couple of key developments that have happened in the market from a technology perspective. The first one is within the IT space, everybody's sort of become very, very comfortable with virtualization. So a lot of data centers now are probably 60 to 70% virtualized compared to a few years ago when probably less than 10% of the data centers were virtualized. So instead of sort of in the olden days, you sort of wanted to have an application achieve higher performance, you'd actually look at the application, break it into different components, deploy it in multiple different systems. But now you have the ability to not necessarily have to break up the application, but also be able to take your application and have it sort of virtually distributed around different parts of your infrastructure. So the application actually is not necessarily tied to the underlying infrastructure. It can actually move around within your environment. The other sort of big change obviously is from a connectivity perspective. We've been seeing dramatic improvements in the speeds that are available to you. So today you probably have more computing capacity coming into your home than you probably do at your office on a per sort of capita basis. We're seeing 4G LTE sort of roll out onto mobile platforms. That enables actually a lot of interesting things to happen from an application standpoint and where these applications can be delivered. And then from a mobility perspective, we're seeing sort of the small form factor of devices, but devices that are inherently very, very powerful in terms of their computing capacity. But one of the interesting things that happens is as the computing capacity increases on the devices and the form factor gets smaller, a lot of the data that that applications that are mobile enabled need to access essentially has to reside somewhere. And in most cases, it resides in the cloud as well. And then finally, from a commoditization perspective, most of the underlying infrastructure components now tend to be commoditized. People can sort of assemble different components, build their own massive computing platforms that we've seen, for example, Google and Facebook do as they built out their infrastructure. And be able to build very powerful systems that then can be utilizing virtualization, can be packaged, parceled, and made available to different types of applications. And then finally, the other sort of key development is really on the self-service side. So while people, historically have built infrastructure, they're building self-service platforms on top of that infrastructure. So the users, whether they're enterprise users or consumers, can access that massive computing capacity, storage capacity fairly easily. These three developments, or these sets of developments that have happened over the last several years, came about, and there were a lot of different names that were associated with what was really happening from an underlying perspective. So many years ago, grid computing was a big term in the marketplace. An application service provider was another big term that essentially was talking fundamentally about the same things. I want to say over the last, I think, 2 or 3 years, the industry sort of has agreed on a nomenclature that basically breaks down cloud into sort of 3 sets of offerings or services. The first is something that we call infrastructure as a service, and any organization that is sort of packaging facilities, routers, switches, the operating system, the routing, DNS load balancing components, and putting some APIs around them can now package what fundamentally has been a very low-level infrastructure offering into a service, and then have people utilize it on an on-demand basis. So the first, iteration or first sort of component of the overall cloud story is something that has now been, pretty sanctified as infrastructure as a service. If you take your infrastructure and then on top of it you can offer some integration and middleware, what you've now done is sort of enabled applications to be written and developed around that infrastructure. So before you would write an application and then you would need to sort of run around and find the actual infrastructure components to run that application on. But today, certain providers are providing you not only the infrastructure, but also sort of the ability to write applications on that infrastructure. That's typically called platform as a service. We see that being offered by Google, for example, through the Google App Exchange offering, from Salesforce.com, for example, using their Force.com platform. So quite a few different platforms that have come about that allow you to essentially create your applications right on the infrastructure itself. And then people that have sort of focused on using a platform as a service, infrastructure as a service, and have built applications on top of it, typically are called software as a service providers. Salesforce.com, for example, is a good application that is considered to be a cloud application delivered as a service to consumers. And there's a whole slew of applications out there right now. In fact, any on-premise application that you see today now has a kind of on-the-cloud competitor to it. So that's dramatically changed the software landscape as well. From a consumer perspective, we had sort of an inflection point towards the early part of last year where there was a huge amount of traffic on the internet now that was coming from what are really cloud-based applications. If you look at it today, between Netflix and YouTube, roughly 30% of all internet traffic is coming from these cloud-based applications. So like I mentioned earlier, we're seeing a change happen from a consumer standpoint where we're not necessarily reliant on our desktops to do most of our computing, but really getting a lot of the information from external sources through high-end connectivity, both on our mobile devices as well as on our desktop environments. Similarly, we're also sort of seeing people on the enterprise side get fairly comfortable with utilizing the cloud. So there are quite a few interesting use cases for the cloud today. One of the most prominent one is really looking at doing media distribution from the cloud. So anytime a software provider rolls out an update to their application, they're not shipping out CDs anymore, but directing people to websites that will then do mass distribution of updates to their application. Similarly, enterprises that are building applications typically would rely on test and development environments within their enterprise. So one of the interesting use cases we're seeing today is people that are building software products actually having the testing and development environments associated with that product being located in the cloud. We're seeing a lot of applications for disaster recovery. So disaster recovery historically has been something that either has been very costly to implement, or in slightly dramatic cases, people have sort of opted not to implement full-blown disaster recovery because of the associated costs, and at the same time then putting their business at risk. So having the ability to get infrastructure on demand has sort of made it easier to make a pretty solid business case for disaster recovery applications, and kind of bringing the costs in line with something that is affordable from an enterprise perspective. The other thing that we're also seeing is kind of traditional business applications that you see, whether it's your ERP platforms, your CRM platforms, all now being available and utilized on and delivered from a cloud perspective. So, traditional e-business applications from Oracle are now available on various cloud platforms. SAP sort of recently has made a big push to have a lot of their products available on cloud platforms as well. Something that a few years ago probably would have been unthinkable, because these enterprise applications are very tied to being provisioned in local data centers. And then what you sort of see happening from a cloud perspective is a dramatic shift in the thinking within different IT departments. And the way that we sort of characterize that is that people are sort of moving away from the mode where everything was based on procuring things to looking at seeing how you could provision things. So if you go back a couple of years, if you created an application or you had some needs, you would call in your team that is responsible for the infrastructure. More than likely, they would have to go out to one of their providers, whether it was Dell or IBM or HP, whoever's computing servers that you were using. Then they'd go to their data center provider and say, look, we need additional rack space or co-location. Then they'd go to their bandwidth provider and make sure that they had enough sort of bandwidth to handle new applications. So there's a whole sort of process involved around procuring those services and getting them ready so that they could support applications. Today, based on the self-service abilities that are available in the cloud, you're not really procuring things, you're actually provisioning them. Everything is available pretty much on an on-demand basis. You look at your application, you profile it, and then you essentially are going through a menu of selection that you click through to get infrastructure provisioned. So it's a dramatic sort of shift in thinking, and one way to sort of view it is that your traditional requirements are sort of moving away from sort of hard type of procurement, hard type of deployment, to really a software, almost a software-based world where essentially you're pointing and clicking on certain components in and getting them provisioned on demand. And that sort of has a pretty dramatic impact on how you sort of set up your business as well. That's sort of being enabled primarily because the level of abstraction that historically has been enabled to provision systems has changed dramatically. So people have created pretty good standardized ways to access router switches, so you can provision them automatically or programmatically. And those have sort of been captured and essentially being presented as APIs today. So before, if you had to order a server, you filled out all your POs and you shipped them. Today, if you order a server, you're essentially making a call to a pretty rich and full feature set API that your providers have created for you. An example would be if I look at, let's say, compute capacity, I can go today and literally in seconds launch pretty substantial computational systems, either through the Amazon cloud or through the Microsoft cloud or to some extent to the Google cloud as well. And all of that is really being enabled because what used to be hardware features are now presented essentially as software-enabled points that can be manipulated to get these systems set up and kicked off. So we are moving, again, from a very hardware-centric environment to fairly software-centric. So today, we can envision a time when, just like how software companies release product versions, they may have point releases, they may have major releases. We should look at hardware and hardware services and infrastructure as a service being exactly like that, where there are point releases for your infrastructure provider, and then there are sort of major releases, and each one of them has different capabilities that you can leverage going forward. There are, just between what are known as GAMI, which is Google, Amazon, Microsoft, eBay, Yahoo, AOL, there are probably about 3,000 APIs that have been made available that allow us to not only leverage some of the data that these companies have, but really be able to control and manage the infrastructure component as well. And we see, hundreds and thousands of sort of interesting ways of how people are utilizing these various APIs to do fairly interesting things, but at the same time sort of doing them very, very quickly and without sort of having large-scale upfront infrastructure-based investments that they need to make. From an enterprise perspective, and this is a slide that I've actually borrowed from our colleagues at Amazon Web Services, really from an enterprise perspective, what really happens is that historically your capital expenditure had been a fairly step-oriented function. You'd set up a data center, you'd see how long it took to fill it up, and then you'd make a very large-scale capital investment into your next data center and wait around for it to fill up. So at one point in time, you'd have sort of excess capacity, and another point in time, you'd have actually capacity that is not necessarily tied to what your actual demands are. So when your capacity is more than what your demand is, you're sort of wasting money. And then when your capacity is lower than what your demand historically has been, then your business is at risk. So what the automation and orchestration in the cloud allows us to do is actually procure infrastructure, get the application set up in a way that's really tied to what your business requirements are. So if you need computing capacity or storage capacity today for some episodic type of event, you can get it on demand. Tomorrow, if that demand slows down, then you can actually shut down that capacity and stop incurring the costs that were associated with it. So again, between the ability to get access to infrastructure through automated, orchestrated ways can actually allow you to really map your requirements and your costs that are pretty tied to what your actual business requirements are for the infrastructure. Let me talk a little bit about sort of what our focus historically has been. As an IT provider, one of the things that we're always doing is looking at ways on how we can help our customers optimize their IT spend. and sort of help them look at new technologies and be able to leverage them towards their existing projects or future projects that may come along. So within our organization, we have a group that we call DISYS Labs, and that's primarily focused on looking at how do you leverage cloud, for example, to rapidly enable applications for our customers. Because what we've seen is that there is the ability now today to access infrastructure on demand, do it in such a way that your costs are fairly contained. But the challenge then becomes, how do you then get on to that infrastructure? The analogy that we like to use is that we've sort of built a very, very good highway. It's an 8-lane highway, but we still feel that the on-ramps to the highway, need some enhancements to be done, and that's really where our focus is on. We've got a great platform that allows companies to optimize their costs. Let's make it sort of easy for them to actually get their applications on it. So our focus historically has been, and where we spend a fair amount of time on, is how do you rapidly get applications onto the cloud, what's the best way to do it, and how do you get probably the largest portfolio of applications assembled that you can put onto the cloud. From our perspective, our focus has been to look at the existing APIs that are available from the different providers, look at some of the applications that make sense to move on the cloud, and then sort of marry the two. Come up with the ways where we're doing fairly automated deployment of different applications, and at the same time, we've got a fair amount of self-service components so that an enterprise can maintain, manage the control of the allocation of the assets. So they're not sort of in an environment where just because it becomes really easy to provision systems, they end up in the problem that they've always had within their traditional data center environments, which is a problem of server sprawl. So in one sense, we have to be very careful when things become very easy to provision. There's always the ability to over-provision them. So you want to make sure that there are self-service cloud operations capabilities available to our customers so that they can control and manage those costs as well. So we spent a fair amount of time in looking at the APIs that are available and how we can actually build some intellectual property that can be shared with our customers as well as our prospects as well. So some of the application scenarios that we're looking at are, how do you take existing on-premise applications and move them onto the cloud? How do you look at sort of the ongoing maintenance support of those applications? And the initial use cases that we're focusing on are essentially deploying applications that can be utilized in a pilot or proof of concept perspective. This could be product demos that you're setting up, or for your internal users or external users, some short-term proof of concept system that you're setting up. Looking a lot at one of the use cases that I mentioned earlier, which was the test and development use case. So all our customers and enterprises around the world are always developing applications that help them optimize their business. So being able to provide sort of an on-demand test and development environment for our customers is one of sort of the applications that we are considering and have sort of optimized the rapid enablement platform around. So how do you sort of get a little bit deeper into and talking about how we do that? The first thing is, if, for example, in our case, we are an Amazon Web Services solutions partner, so one of the first cloud solutions that we've been looking at to rapidly enable applications on is the Amazon one. And this is where we focus on looking at how do you build machine images, how do you look at the different components that go into the machine images, and then look at sort of some of the CloudFormation templates that and the APIs that are available through the Amazon cloud, and then be able to automatically generate the CloudFormation template based on customer requirements, and then actually get these applications configured, set up, and fairly automatically and seamlessly launched from our platform or a platform that where we use our technologies to customize our customers' existing platforms. So a fair amount of exercise and energy spent on really understanding how do you make this process completely seamless, how do you make it so that it's extremely efficient, but at the same time it's also giving us great visibility into what's going on at any given point in time. Some of the applications that we focus on initially, are ones that you may have, you may come across in your enterprise as well. People are looking at various content management systems today, whether it's WordPress or Drupal or other sort of open source platforms, and they're doing that to either host internal content, or it may be to host your external websites. Moodle is a learning management system, pretty popular learning management system, primarily used in the higher education space. We're seeing a lot of deployments on the enterprise space as well. SharePoint, obviously, everybody is fairly familiar with. Active Directory is another application. I mentioned a lot mentioned about SAP sort of being fairly involved in seeing how their applications can now be deployed on public cloud infrastructure. They've certified, I believe, a few different providers to do that. So we've actually looked and automated the deployment of SAP test and development environments as well. One of the ones that I'll sort of spend a little bit of time on in the next few slides is really the MapReduce application. And this is sort of where people are looking at ways to utilize their data that they've assembled, whether you're a retail organization, healthcare organization, and other telecom organizations. You're collecting lots and lots of data at all times, and that's a very interesting application because the usage and the analytics that you do around the application may be very episodic. You may be doing it once a week, once a month, end of the day. So being able to tap into fairly large computing and storage capacity for those episodic events sort of made complete sense for us to make that an application that would be useful for considering for rapid enablement on the cloud. So that's the one that I'll talk a little bit about, where we've actually spent some more energy on and understanding. So the ability to utilize data, and whether you do it correctly or not, can have a dramatic impact on your business. There's a new term that's really floating around in the marketplace called data equity, and that's really sort of saying, how well are you utilizing that data that you're collecting from your customer transactions or from other business transactions to either increase your profit, do more targeted based solution development, or targeted based marketing. Today we are collecting data from scanners, from sensors, from utility meters. All of that sort of either comes in structured or unstructured format and can provide potentially very, very highly profitable insights to your business. Being able to leverage that is really key, and because there's a substantial amount of processing required, MapReduce, a technology that was developed by Yahoo and then sort of optimized by Google and a few other organizations, is a pretty solid sort of solution that can be built on the cloud. So we've actually spent a fair amount of time building out a big data MapReduce framework that looks at the initial data set, looks at how you define what kind of computing capacity, storage capacity you would need, actually launch that storage and computing capacity on demand, go and get the data, do the data processing, and then enable you to actually take all the processing that's being done and put it into whatever your analytics engine is, and then be able to extract valuable, potentially profitable information from that. Being able to sort of do all of this in an automated, orchestrated manner primarily has come about because we've been able to understand the APIs that are available through various service providers out there. So again, a very good, solid case that that we've sort of utilized for the rapid cloud enablement application use case. The offering that we've sort of evolved to after sort of learning about the cloud, looking at the applications that could potentially be deployed on the cloud, and then looking at ways to creating that easy on-ramp for our customers, has sort of evolved into an application that we call Zero. It is going to be formally launched in about a week and a half at the Amazon reInvent conference in Las Vegas. So what we'll do right now is just go through a very brief demo of the application, and then if you guys have any questions, this will probably be a good time to start entering them into the chat room as well. So this is, I will actually share the application with you. So this is sort of a simple portal-based application that you can log into. And depending on which customers we're engaged with and what are the use cases that we work with them on, we'll actually provide our customers with a set of templates that are available and set of applications that are available for them specifically to be able to use. So if you're working with a customer that is really focused on utilizing the cloud for example, for website hosting, what we'll have available for them are stack templates that really mimic and sort of serve their specific use case. So they may have sort of requirements for marketing websites that are supporting their large-scale corporate websites, or they may have micro websites that they launch for specific brands within their business. So the stack templates would sort of allow the customers, our customers, to be able to launch infrastructure that is associated with their particular application. So for different customer base, there will be basically lots of different categories of applications that they can launch. One of the ones that we talked about was the big data one, where we can actually launch MapReduce applications for our customers. In this case, we're using a pretty popular Hadoop release that Cloudera has been offering. So in this case, for our customers that want to do some big data analysis, we've got a pretty decent 4-node cluster that we can launch pretty quickly. If you are in the SAP space, we've got a couple of different platforms that are enabled right now. This is sort of a ERP system that does not necessarily launch the full SAP suite, but a few components of the SAP suite. And like I mentioned earlier in the presentation, we're targeting the test and development use case for it first. So when you click and launch these servers, you would essentially be launching the test and development environment of those servers. So a fair amount of different types of applications that we are enabling for our customers today. Okay. Hopefully everybody can see the screen right now. Another example that I'll sort of give for traditional sort of enterprise-related applications include the Active Directory application the SharePoint application as well. So what I sort of want to have the takeaway for most people here is that the different types of applications can be easily added to the platform, and then depending on which one you actually select, you can quickly launch these applications. So, we go into this point-and-click system. We can select, for example, Active Directory platform, and then add some specific configuration points to it, and then those servers would actually get installed pretty seamlessly into the cloud environment as well. And the final point that I'll sort of make is that not only do you want to sort of launch these applications, you do want to keep an eye on these applications as well. So what the system will allow you to do is actually, once these systems are up and running, be able to keep track of and see how these applications and the infrastructure that you're running is actually doing, whether it's installed, how long it's been running, whether your users are actually using it as well or not. We also do have the ability to make sure that we can service customers and their infrastructure requirements across the different locations. So today we are leveraging Amazon's cloud deployments pretty much around the world. So we've got Tokyo, Singapore, Sao Paulo, Ireland, and pretty soon we will be adding Sydney here as well. So depending on your specific enterprise requirements, you could have systems deployed very close to your customers or other parts of your enterprises. So instead of having everything being located in one place within the U.S., you have the ability to get fairly close to your customers as well. So again, this is a quick, brief introduction to the platform. We've tried to show samples of different enterprise applications, but this is not sort of the whole exhaustive list. There's a lot of things that we can do and add as we go along and work with our individual customers as well. Let me sort of go back to the presentation, and we're getting close to the end here. So I'll just start entertaining questions. I know there's a few that are already up, so let me just get to those as well pretty quickly here. Just 1 second as we get to the slide deck. So from a DISYS perspective, we built a fair amount of intellectual property around being able to enable applications on the cloud. But one of the things that we also do is not just help customers on the front end, but be able to provide a full lifecycle support services. So we can help you look at your existing platforms and applications, determine which one makes sense to get on to a cloud, and then actually do the migration, set up the systems, and then not necessarily leave you at that point, but be able to provide some ongoing support and services as well from a 24/7 monitoring management of those applications once they've actually got on to the cloud as well. The way that we work with a lot of our customers as they move and consider cloud as a way to optimize their costs and sort of bring their infrastructure to be able to leverage both public and private clouds. We sort of have a pretty defined assessment process. We look at your existing application, determine which one makes sense or not, look at it both from a technical perspective as well as a financial perspective, and then look at actually building out the architecture that would be required, doing a proof of concept, doing some migration, and then So rounding off everything by having a pretty defined run book associated with that. Our intent is that whether you use new technologies such as cloud or you stick with your existing infrastructure, whether you're building private clouds or not, we want to make sure that there's no additional operational overhead. So you don't want to be in a situation where you make investments in new technology, but your total cost of ownership, because the support costs sort of become a substantial portion of it, mitigate any of the benefits you may get from new technologies. So we do want to make sure that while we're deploying new technology, it's optimizing your infrastructure, but at the same time, it's also not an additional burden on your support costs. So we do spend a fair amount of time in the runbook development and implementing best practices around the support of your application as well. So this is the end of our formal presentation, and let me sort of start addressing some of the questions that we had from the various users. So the first one really are, we've talked a lot about public cloud. The question was, how do you do private cloud implementation, and what is specifically DISYS's role in providing services to that segment? So on the private cloud, the way that we view our investment in developing IP for the cloud space is fairly agnostic. We're not necessarily tied to private cloud or public cloud. What our real focus is on looking at options where the APIs are the most feature-rich, so that allows you to be able to build the orchestration that gives you the benefit of utilizing the cloud. In the case of private cloud, we focus a lot on OpenStack and CloudStack, which essentially allows enterprises to build public cloud-like infrastructure which has a self-service component, but do it utilizing their existing assets around that. So we do have sort of expertise in doing that, and we think that's a really good option for a lot of enterprises and a lot of very specific applications where the public cloud may not make sense. The other thing that we also do look at is that private cloud implementation can also occur in certain public cloud-based environments. So you can create very defined private clouds in public infrastructure where you're not actually exposing your applications in any way to sort of the public side of the infrastructure as a service providers as well. So that's sort of a quick and short answer to the question. The other question is, can our product Zero be provisioned as a turnkey product in a private cloud scenario or as a managed service? So the answer to that is yes, for both. If we are looking at Zero and you want to have sort of the backend infrastructure be a private cloud that you've deployed, whether it's a VMware-based cloud or OpenStack-based clouds, the ability for APIs to sort of interact with the backend infrastructure is fairly easy to adapt to, and we've done that in a few cases. So that's definitely doable as well. Our approach to Zero is, and again, I'll sort of be very clear, DISYS is not a software company. We're a services company, but we do make a lot of investment in IP because we think it adds value to the way that we deliver our services to our customers. So we can help you rapidly enable your enterprise with utilizing our Zero platform, or if you feel that you also want us to sort of be the ongoing managed services provider for you for your cloud implementation, then we're happy to play that role as well. The other question was really on the security side. So that's a pretty common question that comes around in, what are sort of what is my security exposure when I'm looking at porting my applications to the cloud. And the way to sort of answer that is that security in the cloud is really a shared responsibility. So your cloud provider, whoever you select, has the sort of mandate to make sure that the infrastructure side of it is fairly secure, and they're sort of taking care of that. The other component of that is that because you can get this infrastructure on demand and you can deploy pretty much any application on it, the security of the application side really is your responsibility, or if we are your partner, then it would be our responsibility to make sure that we implement pretty robust capabilities around the security side. Right off the bat, what's really interesting is that there are a lot of security enhancements that can be deployed in a public cloud environment. So if you were using intrusion detection systems, you can get those available to you as well. If you were utilizing some sniffing type tools or other ACL type tools, those can be deployed in your particular implementation on your part of the public cloud. So you'll have definitely access to the security components that the provider is offering up, but then you have the ability to deploy pretty much any component that adds to the robustness of your security profile as well. The other question that we have is, who owns the data once it is in the cloud? If it's in the public cloud, who's really the owner of that data? And the way that I'll sort of answer that is that the customer ultimately owns that data. So they have the ability to sort of request the destruction of that data. They have the ability to sort of protect that data in any which way they want. They have the ability to encrypt it without having to sort of provide your provider with the ability to decrypt that data. So all of that is in your control, and you can essentially manage it more or less in the same way that you would if it were deployed in your data center on your premise as well. So these are sort of quite a few questions that came about from the team as well and the attendees. So at this point, we're getting close to the end of our presentation here. There are probably 2 or 3 other questions that are coming in, and I'll sort of address those as well. Right, one of them is sort of talk, a lot of, or asking about sort of the cost benefits of moving to the cloud. One of the things that you always want to consider is if you have the ability to align your business requirements to the costs associated with running your business so that you don't have sunk costs or you don't have any unexpected costs, that is an option that most companies will choose for. So from a cloud perspective, because it does give you fairly granular ability to add infrastructure to your existing data center, it has the ability to take away infrastructure when your utilization is done. It allows you to map your costs directly to when you actually should be implementing that infrastructure. So you'll see over time a fair amount of cost savings. You'll have less sunk cost from an IT perspective, and you'll have sort of mostly nicely aligned costs to your business requirements. In certain cases, and again, cloud and infrastructure is not a perfect solution for everything. In certain cases, it might be more expensive for you to utilize the cloud, but you may be ready to pay the premium because it does serve an immediate business need. So when you need episodic, for example, utilization. So you might be running a pretty large marketing campaign, and you may need dozens of servers. And if you did the modeling around it, you could say, well, it might be cheaper for me to go out and procure those servers and deploy them myself, but it might be quicker to do it if you utilize sort of an on-demand solution for it. So you'd have to weigh sort of the time value versus the actual absolute dollar amount that you're spending on a particular infrastructure to meet a particular business requirement. So again, a lot of these things do get down to individual use cases, but by and far, what we're seeing is that there are definitely greater advantages to having a variable cost structure that you have complete control over than infrastructure that's or cost basis that is sunk in or that has a pretty high step function each time you need to enhance your infrastructure or build infrastructure to deploy new applications to satisfy your customers' needs. So I want to thank everybody. I believe we've addressed all the questions that have been presented so far. I want to thank everybody for attending the call today. And if you have any other questions, please email them to us at any given point in time. You will be getting this presentation sent to you later this afternoon or tomorrow, and then the recording of this webinar is also going to be available on the DISYS website as early as tomorrow. So once again, thank you for attending, and hope you get the opportunity to work with you in the future.